These are exponential functions. The inverse of an exponential function would be a logarithmic function. So we still start by switching the location of x and y. Now you can either rewrite this equation in logarithmic form, like we've done before, or you can take the logarithm of both sides. I would use log base 4 in order to take advantage of inverses. Log base 4 of x is the inverse of exponential 4 to the x power. Number 2, switch x and y. As a first step, add 5 to both sides. Take the logarithm of both sides. I would use a base 3. Put parentheses around everything that existed on the left side of the equation before you took the log base 3. We used log base 3 in order to activate inverse property. It's important that x plus 5 is shown in parentheses to indicate that you take the logarithm of the entire expression. Order of operations is very important to show clearly. Number 3, switch x and y. This time with the exponent, the entire exponent, y plus 4, nothing else added or subtracted to the expression, we start off by taking the log of both sides. I would take log of 10, log base 10. I don't have to write that 10, but it's automatically a base 10. We can use the inverse property. Now we have log of x, that's automatically log base 10, equals y plus 4. When I subtract 4 from both sides, it's important to realize it does not go into the argument of the logarithm. I don't necessarily have to have those parentheses around x. I used them to emphasize that the 4 does not belong with the x. It belongs with the entire log of x. Number 4, switch x and y. First step, subtract 1. Then take the log of both sides, base 2. That allows us to use an inverse property. And last step, add 3 to both sides, which will be automatically outside of the argument of the logarithm.